nice polynomial equation, okay? So m exponent 9 plus m exponent 6 equals 36. So 9 is the same as 3 times 3, and 6 is the same as 3 times 2. So our equation becomes m exponent 3 times 3 plus m exponent 3 times 2 equals 36. All right, so let's apply the power of a power rule of indices. So we know that a exponent m times c equals a exponent, okay, c, okay, exponent m, or a exponent m times c. So a exponent m times c equals, okay, a exponent c multiplying the exponent m, or a exponent m multiplying the exponent c. Okay, so the exponents are interchangeable. All right, so we are going to have, okay, m cube exponent 3 plus m cube exponent 2 equals 36. All right, here we are going to say let a represent m cube. So equation becomes, okay, a cube plus a squared equals 36. So now we have a cubic equation. All right, so let's transpose 36. So we are going to have a exponent 3 plus a squared minus 36 equals 0. All right, so our equation becomes, okay, a cubed minus, a cube or a exponent 3 plus a squared minus, now 36 is the same as 27 plus 9. All right, so our equation becomes a cube plus a squared minus 27 minus 9 equals 0. Okay, so you're going to have a cube plus a squared minus 3 cube minus 3 squared equals 0. All right, so let's group the cubes at one side and the squares at one side, okay? So you're going to have a exponent 3, okay, minus 3 exponent 3 plus a squared minus 3 squared equals 0. All right, so you can see these are the cubes and these are the squares. So we are going to apply the difference of cubes identity here, okay, and the difference of squares identity here. Okay, so let's quote the difference of cubes identity. So a cube minus b cube should give us a minus b times a squared plus ab plus b squared. All right, so we're going to have a, okay, minus 3, okay, times a squared plus 3a, okay, plus 9, okay, and then here we have a squared minus 3 squared equals 0. All right, so we have applied the difference of cubes identity. Let us apply the difference of squares identity, okay? So it says that a squared minus b squared should always give us a plus b times a minus b. So it gives us this binomial. So our equation becomes a minus 3 times a squared plus 3a plus 9 plus, okay, a plus 3a minus 3, okay, equals 0. All right, so let's factorize. So you can see this here, and then you can see it here. So a minus 3 is common. All right, so you're going to say, okay, a minus 3. So we are bringing the common ones, the common terms out. So a minus 3. And then we are left with a squared plus 3a plus 9, okay, plus a plus 3 equals 0. All right, so you're going to have a minus 3 times a squared plus, now 3a plus 3a plus 9 plus a plus 3 equals 0. All right, so our equation becomes a minus 3 times a squared plus, now 3a plus a is 4a, 9 plus 3 is 12. All right, so this is what we have. All right, so now we are going to apply the zero product property. Okay, so it says that if a equals 0, then, if a times b is 0, then either a is 0 or b is 0. So in this case, we can say this part stands for a and this part stands for b. Okay, all right, so let's solve it. So you can see if, okay, so let's do it. Okay, let's do the whole thing again. Okay, so if a times b equals 0, then either a is 0 or b is 0. All right, so our equation becomes a minus 3 equals 0. Let's call this equation 1. Okay, and then we have a squared plus 4a, okay, plus 12 equals 0. Let's call this equation 2. All right, so from equation 1, a minus 3 equals 0. So a is equal to, a equals 3. We can say a1 is 3. Okay, a1 is 3. All right, from equation 2, we have a squared plus 4a plus 12 equals 0. All right, so let's use the determinant to check our equation. So we know that delta equals b squared minus 4ac. Okay, now before we apply the determinant equation, let's state as squared plus bx plus c equals 0. So let's use this to derive the values for a, b, and c. So you can say when we compare, we discover that a equals 1, b equals 4, and c equals 12. Now let's use the determinant equation to check. So delta equals b squared minus 4ac. Okay, so delta equals 4 squared minus 4 times 1 times 12. So you're going to have equals 4 squared is 16. 4 12 is 48. So you can see we are subtracting a very big number from a very small number. So you can see delta is negative. Okay, so this equals negative. Okay, so the answer we get is negative. Therefore, okay, or we can say since okay, b squared minus 4ac, okay, the determinant is given is, okay, is less than 0, the equation has complex roots or solution. Okay, so in this case, we are looking for a rare solution. So we are going to ignore equation 2 and focus on equation 1. Okay, so from equation 1, okay, we discovered that. So let's reference equation 1. All right, so from equation 1, a equals 3. Okay, from equation 1, a equals 3. Okay, but a stands for m cubed. Therefore, we can say m cubed equals 3. Okay, so m equals the cube root of 3. All right.